हेलो एवरीवन, स्वागत है आपका यूनिवर्सिटी एकेडमी यूट्यूब चैनल में। आज के लेक्चर में हम लोग देखेंगे एलसी एंड आरसी नेटवर्क का रियलाइजेशन यूजिंग द फॉस्टर सेकंड फॉर्म। प्रीवियस लेक्चर में हमने फॉस्टर फर्स्ट फॉर्म कंप्लीट किया था। आज हम फॉस्टर सेकंड फॉर्म स्टार्ट करेंगे एंड उसमें वी विल सी एलसी एंड आरसी नेटवर्क रियलाइजेशन। अगर आपको इन टॉपिक्स के हैंड रिटन नोट्स चाहिए, लिंक इज गिवन इन द डिस्क्रिप्शन बॉक्स, यू कैन डाउनलोड फ्रॉम देयर। और वीडियो अगर आपको अच्छा लगे तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें। लेट अस स्टार्ट विद द फॉस्टर सेकंड फॉर्म। This is also known as admittance form. Foster first form is known as impedance form because उसमें जो हम network synthesize करते हैं वो हम ZFS function से करते हैं. Okay, let me write. In the Foster first form, we have seen that we synthesize the network using ZFS. That is why it is known as impedance form. But जो Foster second form है just opposite है to that of the Foster first form. In the Foster second form, we work with the admittance y of s. Okay, that is why it is also known as admittance form. अगर क्वेश्चन में सपोज अगर आपको z of s गिवन है बट यू हैव टू रियलाइज Foster second form, देन सबसे पहले आपको उस इम्पेडेंस से एडमिटेंस कैलकुलेट करना पड़ेगा. हाउ यू विल कैलकुलेट? वी नो दैट y of s it is equal to 1 by z of s. Okay. Next point is Foster second form have just opposite combination of the element than that of the Foster first form. We have seen that in the Foster first form we connect the elements in series. Okay. यहाँ पे क्या है कि जो हमारे पास elements हैं in the Foster first form they are connected in series. Okay, like this. This is Foster first form. इनसाइड दीज ब्लॉक्स एलिमेंट्स जो है वो पैरेलली कनेक्ट हो सकते हैं बट आपस में दीज ब्लॉक्स विल बी कनेक्टेड इन सीरीज. वी विल बी गेटिंग दी जेड ऑफ एस. ओके, we will be getting z of s. This is Foster first form, but in Foster second form we have blocks or element they are connected in parallel, like this. Okay, जो blocks हैं they will be connected in parallel which is just opposite. It means Foster 2 may we will connect the elements in this form, then we will be getting the value of admittance because in parallel it is easier to calculate the admittance. इसीलिए हम यहाँ पे YFS function use करेंगे. It means in the Foster one, if we have series, it means if elements are connected in series, then in the Foster second form it will be connected in parallel. Okay, and within the block जो elements हैं वो parallelly connected है. In the Foster first form, Foster second form में they will be connected in series. That is why Foster 2 form is just opposite to that of the Foster first form. This is Foster second form. Okay, again using the Foster second form we can realize LC network, RC network and R of L network. Okay, इन तीनों network को हम synthesize कर सकते हैं and in today's lecture we will see the synthesis of LC and RC network using the Foster second form. Okay, and you also know that in the Foster form we use partial fraction method to synthesize the network. Okay, तो चाहे Foster form first हो या second हो, we will be using the partial fraction method. Okay. Now let us see LC network realization using the Foster second form. सबसे पहले let us see the general circuit. Okay. As it is LC network, it will not contain any resistor. Okay, there is no resistor. अगर resistor नहीं है तो network के अंदर कोई भी loss नहीं होगा. This is lossless network. Okay, now its general circuit will be, we have seen that elements will be connected in parallel in the Foster second form. जो inductor and capacitor है they will be connected in parallel. Okay, this is inductor and this is capacitor. Then we have a series combination of L and C and they will be connected in series and together they are connected in parallel. Okay, it is like this and up to nth element. This is inductor and this is capacitor. Okay, now this will be L0, this is capacitor C0, this is L1 C1. Similarly, this is L2 capacitor C2, this is Ln inductor, and this is Cn capacitor. So now here we will find the admittance, which is Y of S. Okay. So now in order to obtain the general equation for this LC network in the Foster second form, first of all we have to replace this inductor L by SL, and capacitor को हम लोग replace करेंगे by 1 by CS value. Okay. So in order to obtain the general equation for the LC network in Foster second form, replace L by S into L, and the capacitor, it will be replaced by 1 by C of S to make them impedance. Okay. So let me draw the circuit in the next slide. So it will be, so this is inductor, okay, this is capacitor, then we have series combination of inductor and capacitor, similarly inductor and capacitor, and so on up to last element. Now let us write their values. So inductor, it will be L0 into S, and capacitor, it will be equal to 1 by C0 into S. So this is L1, so it will be equal to S into L1, S into L2, S into Ln, and capacitor, it will be equal to 1 by C1S, 1 by C2S, and this is 1 by Cn into S. Okay. So here we will calculate admittance Y of S. Okay. So as all these elements are connected in parallel, first of all we will solve this series combination. Okay. So we will solve the network for the series, because inductor and capacitor, they are connected in parallel, and they will be connected in parallel with this inductor and capacitor. So we will solve this series parallel combination first. Okay. Then we will calculate the value of admittance. So now as they are connected in parallel, so the total admittance है circuit का, it will be y1 plus y2 plus y3 up to y of n. Okay, so first branch का जो admittance है, it will be given by 1 by, because we know that admittance is equal to 1 by z, so it will be equal to 1 by L0 into S. Similarly second branch का जो admittance value है, it will be given by 1 by C0S. Similarly for the third branch, admittance will be equal to 1 by SL1 plus 1 by C1 into S. Okay. And similarly for the last branch, admittance will be given by 1 by S into Ln plus 1 by Cns. So let us simplify this equation. So Y of S, it will be equal to 1 by L0 into S, it will be equal to C0 S plus, let us take the LCM. So this will be equal to 1 by LCM will be equal to C1S. So this will become L1 C1 into S square plus 1. Okay. Similarly second term we can write for 1 by, so it will be L2 into C2 S square plus 1, and LCM will be equal to C2 into S. Same pattern we can follow. Similarly for the last element, it will be equal to Ln Cn into S square plus 1 by C of n into S. Okay. Now this Y of S, it will be equal to 1 by L0 into S plus C naught S. Okay, just a second. Okay, so C naught S plus, then it will be equal to C1 S by 1 plus L1 C1 into S square plus C2 into S divided by 1 plus L2 C2 into S square, so on, plus Cn into S by 1 plus Ln Cn into S square. Now we will make the coefficient of S square as 1. So make S square coefficient as 1. Okay, so uske liye we have to take L1 C1 common. From here we will take L2 C2 common. Okay, so this will be equal to, so y of s, it will be equal to 1 by L naught into S plus C naught S plus this is C1 into S. So we will take L1 C1 common, so this will be equal to 1 by L1 into C1 plus S square. Similarly, from the second term, this is C2 into S, we will take L2 into C2 common. So this will be equal to 1 by L2 into C2 plus S square. And similarly, for the last term, this is Cn into S by Ln into Cn, 1 by Ln Cn plus S square. Okay, so we can cancel out the common terms. So from here C1 will get cancelled out, C2 and this Cn will get cancelled out. So now we are getting, y of s expression. So it will be equal to 1 by L naught S, this will be equal to C0s plus, it can be written as S by L1 by 1 by L1 C1 plus S square. Okay, similarly we can write S by L2 divided by 1 by L2 into C2 plus S square, so on. It will be equal to S by Ln divided by 1 by Ln into Cn plus S square. Okay, so this is the general equation for LC network in the Foster second form. Okay, so you have to remember this equation. So this is general equation for LC network in Foster second form. Now let us see next topic, which is RC network realization using the Foster second form. So जैसे हमने LC नेटवर्क की इक्वेशन, जनरल इक्वेशन डेवलप करी फॉर द फॉस्टर सेकेंड फॉर्म, सिमिलरली वी विल डेवलप द जनरल इक्वेशन फॉर RC network also. Okay, so सबसे पहले we will see the general circuit. So as it is RC network, it will consist of only resistor and capacitor. There will be no inductor. So in the Foster second form, we have to connect the elements in parallel. So it means resistor, it will be connected in parallel. Okay, then we have capacitor, it is connected in parallel. Then we have series combination of R and C. Okay, so this is series combination of R and C and it will be connected in parallel. Similarly, we can have another series combination of resistor and capacitor and so on, like this. So ये क्या है, एक जनरल सर्किट है फॉर RC नेटवर्क इन द फॉस्टर सेकेंड फॉर्म. So this is R0 and this is capacitor, this is C0, this is resistance R1, this is C1, this is resistance R2, this is C2, this is R of n and this is C of n. Now we will calculate the admittance Y of S. So Y of S calculate करने के लिए सबसे पहले we have to replace the capacitor by 1 by CS. Okay, so we will replace the capacitor by 1 by C into S, because S domain में resistor it remain as it is, and inductor it is replaced by S into L, and capacitor it is replaced by 1 into C. So this circuit has no inductor, so हम change नहीं करेंगे, we will only change capacitor by 1 by S into C. So circuit will become, okay, so this is the circuit. So this is resistance, this is capacitor, okay, then series combination of resistor and capacitor, this is also series combination of resistor and capacitor, and so on. This is resistor and this is capacitor, okay. Now let us write the elements value. So this will be equal to R naught, capacitor है, so it will be replaced by 1 by C into S, so it will be equal to 1 by C naught into S. This is R1, so जो resistor है it will remain as it is, so this is R1, R2 and R of n. This will be equal to 1 by Cn into S, this is 1 by C1 into S, and 1 by this is C2 into S. So now we will solve this series parallel combination, and then we will obtain this Y of S. Okay, so this is Y of S. Okay, so now let us solve series parallel combination of network. So we will be getting Y of S, it will be equal to 1 by R naught plus it will be equal to 1 by, so this is 1 by C naught into S, so it can be simply written as C naught S plus 1 by, then we have series combination of R and C, so it will be equal to R1 plus 1 by C1 into S, then we have 1 by resistance R2, then we have in series with C2 into S, and so on. This is 1 by R of n plus 1 by C1 into S. So now we will take the LCM. So this will be equal to 1 by R naught plus C naught into S plus 1 by, so if we take the LCM as C1 into S, it will be equal to R1 C1 S plus 1. Okay. Similarly, if we take LCM C2 S here, so it will be equal to R2 C2 S plus 1, and so on up to 1 by, it will be equal to R of n Cn into S plus 1 by Cn into S. Okay, so we can simplify it further, it will be equal to 1 by R naught plus C0S, it will be equal to C1S by R1 C1S plus 1, then plus it will be equal to C2 into S by R2 C2 into S plus 1, and so on. This is Cn into S by R of n Cn into S plus 1. So now we have to make S coefficient as 1, so we have to take this term common. Okay, so now let us make S coefficient as 1. Okay, so we have to take R1 C1 common, so we are getting Y of S, it will be equal to, so Y of S it will be equal to 1 by R naught plus C0S, then we have C1S by, so this will be equal to C1S by, so we have taken R1 C1 common, so in the bracket we have S plus 1 by R1 into C1. Similarly, we have C2 into S. We will take R2 into C2 common. So this will be equal to S plus 1 by R of 2 into C2, and so on up to last term. It will be equal to Cn into S by R of n Cn into S plus 1 by R of n into Cn. So now we can cancel out the common term. So from here C1 will get cancelled out, from here C2, and from here C of n will get cancelled out. So we are getting, okay, so we are getting y of s expression as 1 by r naught plus c0s. So this can be written as s by r1 by s plus 1 by r1 into c1 plus s by r of 2 divided by s plus 1 by r of 2 into c2 plus so on. It will be equal to s by rn by s plus 1 by r of n into c of n. Okay, so this is the general equation for RC network in the Foster second form. Okay, again you have to remember this equation. So total आपको 6 equations आपको याद रखनी है क्वेश्चन सॉल्व करने के लिए. Okay, so this is general equation for RC network in Foster second form. ओके, सो इट मीन्स आपको 6 इक्वेशंस याद रखने हैं. अब ये इक्वेशंस याद करना थोड़ा डिफिकल्ट है, तो उसके लिए मैं आपको शॉर्टकट बताऊंगी. सो जैसे मैंने आपको प्रीवियस लेक्चर में फॉस्टर 1 के लिए एक टेबल दी थी जिसमें टोटल आपको 5 वैल्यूज़ रिमेंबर करनी थी. सिमिलरली फॉस्टर 2 में भी आपको 5 एलिमेंट्स की वैल्यू आपको याद रखनी है, जिससे आपको इन इक्वेशंस को याद करने की ज़रूरत नहीं पड़ेगी एंड यू कैन ईजिली सॉल्व दैट क्वेश्चन. सो नाउ लेट अस सी फॉस्टर second form. Just a second. Okay, yeah, so now let us see Foster second form table. Okay, you can take this as a shortcut. So we know that in the Foster second form elements will be connected in parallel. So इस तरीके का कुछ आपके पास क्या है, जनरल सर्किट होगा. Okay, and elements will be connected in parallel. You will be getting y of s. Okay, so first is, if you have मतलब पार्शियल फ्रैक्शन सॉल्व करने के बाद इफ़ यू आर गेटिंग a into s term, it means you will be having a capacitor and the value of that capacitor will be equal to a, because we know that z of s, it is equal to 1 by s into c. So what is y of s? It is equal to 1 by z of s. Okay, so it will be simply s into c. ओके, सो यहाँ पे हमने कैपेसिटर की वैल्यू को a एज्यूम कर लिया. सो दिस इज ऑफ द फॉर्म a इंटू एस. इस तरीके से आप याद रख सकते हैं. देन द कैपेसिटर वैल्यू विल बी इक्वल टू a. सिमिलरली नेक्स्ट एलिमेंट, पार्शियल फ्रैक्शन सॉल्व करने के बाद यू हैव अनदर पॉसिबिलिटी दैट इट कैन बी ऑफ द फॉर्म a by s. सो a by s, it will indicate a pure inductor and the value of inductor, it will be equal to 1 by a. Okay, third possibility can be that you will get a by s plus b. सो अगर आपको इस फॉर्म में वैल्यूज़ मिल रही हैं पार्शियल फ्रैक्शन सॉल्व करने के बाद, देन दिस इंडिकेट दैट यू विल बी गेटिंग अ सीरीज कॉम्बिनेशन ऑफ रेसिस्टर एंड इंडक्टर. एंड व्हाट इज़ द वैल्यू ऑफ रेसिस्टर? इट इज़ गिवन बाय a बाय b एंड द वैल्यू ऑफ इंडक्टर, इट इज़ गिवन बाय 1 बाय a. ओके, देन you can also get fourth one, you can get a into s by s plus b form. So इस फॉर्म में अगर आपको मिल रहा है, then you will getting a series combination of r and c. So value of resistor, it will be equal to 1 by a and value of capacitor, it will be a by b. And last you can get, okay, so lastly you can get a into s by s square plus b. So if you get s square, this means you will be getting a series combination of inductor and capacitor. So inductor की जो value होगी, it will be equal to 1 by a and capacitor value, it will be equal to a by b. So you have to remember this table and this is very very important. Okay, so आज के लेक्चर में हम क्वेश्चन सॉल्व नहीं करेंगे बिकॉज फिर देन वीडियो बहुत ज़्यादा लेंदी हो जाएगा. सो नेक्स्ट लेक्चर में वी विल सॉल्व फॉस्टर सेकेंड फॉर्म क्वेश्चन एंड जो एक नेटवर्क बच गया है दैट इज़ आरएल नेटवर्क, उसका हम रियलाइजेशन वी विल सी यूजिंग द फॉस्टर सेकेंड फॉर्म. सो आज के लिए इतना ही. नेक्स्ट लेक्चर में वी विल सी आरएल नेटवर्क एंड वी विल सी सम क्वेश्चंस. ओके, सो थैंक यू फॉर वॉचिंग.